Everyone, thank you for joining. I'll take a minute or two just to go ahead and let anybody else who wants to join um, to do this. For those of you who are here, there's a link. There are links on the chat in case you want to follow up on the presentation, if in case you want to go ahead and submit a session. And yeah, this is here for grabs. Just let me know if in case you want to talk about something important. Anything related to this, we can argue, we can debate about this too. Yeah. Admit all. Yeah. We can argue, we can debate about this too. The chat room is open. Just ping and I'll try and see what I can. Yeah. And because this is a new topic, I don't think any of us are experts here. So I'm trying to do my best. And I would love the wisdom if in case anybody wants to, um, put in. Cool. We're 1 minute over now, and let's dive in. Well, today's session is quite niche, and this is part of a series that I'm trying to go ahead and make about cybersecurity and generative AI because the more the models are evolving, um the more in my research, the more in my experience, we're trying to take something for granted, and this artificial intelligence is making us a little bit numb in the mind, I feel like. As a professionals, at least I feel like we have a moral responsibility. It's not moral, well, technological responsibility to make sure that the implementations that we do, the implementations that we talk about are a bit safe. Right? That's the ground for this series. Um, Last time, in fact, the time before that, I talked a little bit about the large language models and how secure are they. And within the last month or so, they've evolved considerably. There have been multimodal models that have been doing exceptionally well. Reality is now generated in real time. And that's one of the things that I want to talk about in the next session. I'm still working on that. But uh, there's possibility of real-time models now, real-time models that generate images, videos, sounds. Google VO3 just changed everything once again, like every other week. But, you know, and the buzzword right now is AI agents. When I started to look into AI agents, all of them they seemed like pretty a programming thing that we used to do before, like procedures and the run books that we used to create. So you tell it a task and it goes ahead and does it. It feels like a wrapper around the large language models. But while I dug in, I read a couple of papers, while I did a lot of investigation, it felt like they're not just a wrapper. There's something more going on here. That's what I've tried to dive in. Um, there's not much information how to test around this because there's a whole bunch of hype. So bear with me while we dissect this a little bit. If in case any one of you has more experience with this technology and want to pitch in, just shout out on the chat. We can put that into right. Cool. Okay. Before we begin, this session is being recorded, obviously, and there's it would be available on YouTube later also. I'll post the link on the LinkedIn and Meetups. The user group, this is part of a user group, and the details are below. Yeah, it's on the chat too. Cool. Okay, next. Yeah. By the way, we found a sponsor. That was so awesome. The new company, my friends have started it, and the website is called Strong IT, so Sterk IT. It's a Norwegian website. They do a lot of cloud management and cost management and automation. They got their first client recently. They do outsourcing, insourcing, and all kind of technology consulting. So if any of you is interested or want to find out, go to the website, talk to them. Good. Now that we have that out of the way, a little bit of groundwork. What exactly are we talking about? We're talking about generative AI and the things that have happened around it. So generative AI is basically, how do I put it? Is generative AI is a technique in machine learning in which you feed a lot of data. It learns what that data is about, what are the nuances of that data, and it generates data around it. That's very important to understand because this synthetic data, with given with enough data input points and training data, it actually turns out to be better than the original ones at times. More polished, more refined, more nuances. A couple of years ago, we had a problem with fingers. It's no longer there, as if it was never there. Yeah. The more data you put in, the more it becomes lifelike, and it feels like it is alive and it's thinking. Right? We get to that point, and it's been that's a very important thing that happened in the last 2 3 weeks. I want to talk about that. But basically, what it's doing is based on the data, it's trying to predict what happens next. Example, the sentence there that I've taken as a screenshot from Trend Micro. That's what essentially a large language model is. And the same is for every other kind of generative AI. It's predicting what happens next, what comes next. Every pixel, every sound in a video output and in a text output is a prediction, right? And that has led to a lot of other things, which one of those things is AI agents. Uh, I've jumped directly to AI agents because that's kind of where the industry is going right now. Everybody's implementing agents, Microsoft agents, there's Gemini agents, there's Claude agents, even frameworks around the AI agents have been introduced, like model control MCPs and the agent to agent framework. How would they talk to each other? But in all those arguments, there's one thing that's missing, and that's that a lot of people are not talking about how they're comfortable with the security about this and how can we achieve more security around this. Now, taking a step back, an AI agent is basically a fully autonomous system designed to act independently. So the point here is that we will not need to interact with it, make decisions without intervention. So if in case something happens, an error or something around it, it should know how to go around it and work its way through it. Yeah. They don't just follow instructions, they have access, very important. They can adapt and they can execute. Now, the point that I've said before is that they're not actually thinking, they're actually predicting, right? Now, the thing that they've introduced with agents is that agents now have understanding, and there's a couple of tools given, which, to my understanding, feels a little bit more advanced version of functions that were defined. So now we have APIs that could be called a little bit smarter APIs because the large language models are involved, but APIs nevertheless, functions nevertheless. I haven't found an article or a paper that could disprove that to an extent, because if you dumb it down, it's basically just that. Right? So, for example, there's a function or let's say call it tool for the sake of it, calendar, calculator, and all of those are specific functions and APIs designed to be called by this agent. So this agent has things that it could call, fetch data, mold it, give it in a form that's digestible for the human, right? It has memory, short term, long term, depending on how much money are you able to shell on it, how much do you want it to reflect, how much do you want it to know about you. And then following that, it takes actions. Every plan that is generated is eventually moved back and given as a learning. So now it's not just learning from data, it's learning from your behavior too, which is very important for security because AI defense mostly relies on behavioral analytics. Okay? This is a typical large language model, oh sorry, AI agentic application. There's a user input that is interpreted by a large language model, which is the most famous form of generative AI right now that's being used. It has access to a couple of tools, a browser, weather API, and a lot more. Yeah, RAG is being outdated because of these things a little bit, and then it finds the observation that you were looking for depending on your input, formats the output, gives you an output, and that's what you see as a user, as a human being. There's a lot going on here, and that's one of the reasons the security concerns also arise. Yeah. A couple of examples. And before that, I have to show you something else. Yeah. Mm, yes. While researching about this, I came across a couple of things that AI agents are not the only thing. There's a there's totally different terms going around which have totally different significance, and it's important to understand why. There's something called an AI agent and AI assistant. Uh, when we started, the AI agents are posed as fully autonomous, whereas agents need human intervention for decision. They wait for your insights, they wait for you to say something or course correct them. But AI agents are totally autonomous, they operate independently, no human in the loop. They can produce structured tasks. They can actually do a lot more than just segregating data. They can actually make decisions and transactions and predictions because large language models are involved. Yeah, but when I dug deeper, there were a lot of papers around it, and there's one more category. There's AI. There's an agentic AI too. But the difference between all of these three keeps changing on depending on who you ask. But essentially, AI assistance is a less capable version. It's like a chatbot. It has a command and it gives you a response. The planning, reasoning aspect is very low. There's no autonomous scale at the moment. There's no overarching goal there. Then there is AI agent. They are they are autonomous and they perform a user-defined task. That kind of said that they can work on their own, but there is, according to this paper, they have something that needs to be course corrected at times. They have a predefined goal. That's a distinguished feature of these from the AI assistant. They take a task, break it down, get you to the output. Because of this, there are multi-level agents too. Agents working with agents. Crew AI creates a lot of agents that could work together. Yeah, like a manager agent, a copywriter agent, a whole agency of agents, and they are used. They have very low security. They have moderate security risk because there's somehow a validation from a human or a human designed system involved there. And there's agentic AI, which is posed as a complete automation. So this has very high autonomy rate, and that very reason becomes the security risk, which is also very high because there's behaviors, anomaly detections, and value alignment that need to be done but might not be done because it's completely aligning itself. The multi-step plan for reflection, it could go ahead and work on it, gets an error, doesn't stop there, takes the learning, goes back, and so on and so forth. They have multiple tool access which could work to give them capabilities that could be taken sometimes into legal consequences. Also, I had some cases that agentic AIs have been giving problem and have legal repercussions, which is what companies probably would want to avoid. Now, because of this, there are a couple of examples which would bring down the difference a little bit more. For example, the AI assistance is Microsoft Copilot. It doesn't really do anything much, but it does give you a better result. Now that it's associated with large language models, it looks like it's doing more, but it still needs your input. For navigation, Google Maps Assistant, software development, ChatGPT code, because it doesn't do anything until you ask it to do something. And the same is for robots and e-commerce. Security Copilot again, if you've used Microsoft Security Copilot, it would feel like that you have to ask it a lot and then it does something. That's because it's an assistant, it's not an agent. And there are Zapier agents which have a lot of tools around it, which could be connected to each other and are semi-autonomous now. So you give them a task, they work on it, and they go on. Waymo Taxi is an autonomous agent. Tesla's auto driving is an AI agent. It works pretty autonomously, but there is somehow a human or an intervention always involved as a check. Then there is agentic AI, which Devon was pretty impressive while it wasn't, when it wasn't. Yeah. Klarna's AI assistant, which they've taken back now, was pretty autonomous. So they kind of fired a lot of employees in thousands because they had an AI assistant that could work and correct itself and be at all places together. Right? AutoGPT and Microsoft Security Copilot free version is also available there, which behaves a lot more autonomously. It just keeps track of your system, does remediation depending on how much flexibility you've given it. Now, that's the differentiation that I followed through a lot of papers. So that's my definition for AI and the agents right now. Yeah. So breaking it down, the outer is just reactive agents. Then there's contextual aware who know what is going on, like ChatGPT knows everything about you because of all the resumes that you've shared, your degrees that you've shared, your pictures that you've shared. It has a pretty good idea about who you are and what you are. So that's context aware. Then there's goal oriented agent because ChatGPT doesn't have a goal right now. You have to input it. But then there are agents that could be designed around these large language models whose aim is to do something or achieve something. And let's say one of those security agents is to make sure that your access policies are not violated, right? They're completely implemented. Let's say you want to keep a user out and that should not have any user, then that's the goal of that agent. And it's a very simple goal, but that's a start. And there's adaptive agent, which is mostly right now used in devising worms and computer worms, which are adapting on what operating system or what kind of security they encounter. And there's autonomous agent, you could say they learn and expect independently. They don't even have a goal, they probably make their own goals. And there's an overarching theme, yes, but that probably might not even be a goal. And it might even have capacity of not following the goal and just defining something for its own. That's the AI agent's process. It perceives something, gets a process, acts on it, reasons, learns, and then improves. The picture on the right is what we're going to discuss, and that's where the vulnerabilities kind of populate. Because this agent now can be accessed from anywhere. It could have a lot of things that it can do now because there's a sandbox to execute code. There's a large language model for reasoning. There's internet search that it could go out and find out. And there's document parsing and has memory and large language models to generate images. Now, if you look closer, you will see there's a lot of possibility of making sure that the understanding is corrupted, making sure that the commands are corrupted, making sure that whatever is inputted may lead to results that might not work out. In the previous sessions, I've discussed and probably shown a demo where we could give an image or a URL that had a hidden text that only machines could read, probably white text, most commonly, and it just changes what the output is. The same thing is available here because there's a large language model involved. There's internet search involved. Anybody who has seen any science fiction would know that if a robot is sent to search the internet, it's not going to come back without being an Ultron clone. Yeah, because there's a lot of stuff there that attracts a lot of attention. If the machine starts learning that, then it becomes vulnerable to exploits. Then there is machine itself where the agents are hosted. If the machine's memory or machine's resources are corrupted with in-memory commands, it's possible that the agent could be overtaken by that too. Now, because the agent has access to a lot of things, eventually a lot of other things would complicate too. Cool. And so the challenges, whatever I was culminating to, it boils down to this. There's an existing generative AI risk already. We have ethical, privacy, misinformation regulation, prompt engineering, a lot of other things that I've already talked about. They're already there and they would be part of this new agentic risk. But there's more. This agentic risk actually has now bias amplification because it has probably no human or full autonomy that it's been given. Whatever it thinks, assumes, it just keeps acting on it, getting into a feedback loop that works in whatever way it can. Yes, Anuj, you can have the presentation. It's on my GitHub. It's posted on the chat too. I'll repost it again. Yeah. So what happens here is that the bias keeps amplifying, and it keeps giving the same information and interpretation again and again. Eventually, this becomes a system prompt, and then the agent is non-usable. Then there is over reliance on these these AI agents, which basically means that these AI agents would eventually bring in code that is not very secure, and there would be no capacity to improve those codes, which is happening with vibe coding right now. Yeah. And there's context misunderstanding because famously said, language is up for interpretation, and the interpretation in generative AI's case depends on what kind of language model it is using, the cultural significance of it, the same vulnerability that generative AI already has. But these three are pretty self-explanatory. What triggers the new errors here or new challenges here is that the agent now has full autonomy and has access to resources that are in no way, shape, or form sometimes able to report what has been done with them. For example, it might be possible. A very common vulnerability attack with Linux is that for Windows is when it was possible to exploit the accessibility exe to log into Windows to execute program in Windows even without logging in. That vulnerability had nothing to do with executable exe. It's just a convenient way to access the operating system and its underlying runtimes. That's the access here. So if the interpretation is wrong and the context is misunderstood, there's no easy way to go ahead and diagnose every interaction and see how was it interpreted, because most of these things are black box. The access and autonomy are leading to a bigger threat, which basically means that they might have a lot more going on. And now the attack surface is pretty expanded. Now we have something with high access, high autonomy that's not transparent, so we can't really see what's going on there. Okay? Now, in the recent days, there's another factor that came into the picture. Apple, in its pursuit of Apple Intelligence, released a paper which highlighted one more challenge with AI. Right now, all those challenges that I listed could have been easily taken up for an argument because we have a lot of data and these models seem like they can think. Right? A semi-AGI sort of situation, but a pretty reputed paper was released by Apple. It could be called a diss paper because Apple isn't able to get its AI correct right now. But the paper essentially says that the AI that we have released in the wild is not actually thinking, it's just regurgitating. We all knew about this a little bit, but Apple kind of confirmed it with its experiment and its approach to it. For example, they give a couple of puzzles to them, which are very common for small children to solve. An example was Tower of Hanoi. If it's taken to level 30 or 28, one of those, the LLM agent was able to solve it. But if it's increased beyond that, the level or the number of pallets that are supposed to be transferred, if it's increased beyond that, the agent loses the whole approach, even though the same approach would have worked. Now, this seems like a common sense situation, which even a small child understands how the learning works. But the illusion that was there that the machines are learning and making a generalized assumption has been broken because of this paper. This was a pretty milestone paper, in my opinion, because there's a lot of acceptance for them for agents and models. There's not been a lot of criticism. There's been a surface level criticism, not database criticism, which this paper kind of gives, right? So if there's a high complexity task, even the same approach is not applied by a large language model, which kind of shows there's a deficiency of understanding here. In response to this, Claude published another paper, The Illusion of Thinking. They kind of said that they kind of tried to justify it through token limits and impossible puzzles and all kind of argument around it. But they did not address, in my opinion, the actual problem and did not have a proof. They had a counter proof of something, which is like saying this might not be true, but then it's not possible to say what is exactly true. There's just, in my opinion, muddying the water, but they are more intelligent people there. Maybe I've missed something, and if any of you think that my interpretation is sort of wrong, please do pitch in, let me know. Yeah. The demo was a bit tricky for this one. And unfortunately my machine failed. But there are repos that I've discovered that actually provide testing capacity for this for AI agents and its security, and it's pretty easy setup, step by step given. And I'm going to take you through the registry and the repository and show you how that works out. Um, but before we go there, I'm just going to talk about the solutions and mitigations. Although this is an open discussion up in the air right now for anybody who's involved. The most common consensus around solution feels like there should be guardrails and input-output filters. So whatever comes out needs to be checked by something else, and that something else we're assuming is not vulnerable. We're assuming that something has its own understanding and doesn't fall into the trap of repeating something if it's not given in the proper words, right? And then there's human in loop, which never turns out good because a lot of companies that are billion-dollar always fail because somebody exposes them of using humans. One of the big AI startups just failed because of that. uh, Trying to secure architecture and monitoring. Every company, even Microsoft, is publishing the reports on this, but I'm not convinced how monitoring and architecting hardware or the systems around it would actually function on making sure the output and input is sanitized. Right? There's governance and audits, regular audits, which would be because of the sheer amount of data, might not be a traditional audit. So I'm sort of on the fence for this one. All the sources that I've used for creating this presentation or to condensing the information, this is available here, both the papers, the demos, and all of those reports that have been done. There's a very convincing, there's very convincing uh, test that has been done by Trend Micro on exploiting the vulnerabilities, and they've written a couple of papers around it, a couple of blog posts. It's very interesting to read if, in case you're interested, they actually go ahead and describe how these AI agent security is made vulnerable and what kind of attacks did they pursue. There are four parts of this paper. The first part describes the vulnerabilities. The other ones introduce and go ahead and execute code execution and data exfiltration. Very interesting blogs to read, and there's practical demos for that too. The other repository that I want to mention is uh, this one here, Damn Vulnerable LLM Agent. This is based off a contest that was done in 2023. A little bit old, but still relevant, in my opinion. This can be run in containers and as an application and Olama locally. It gives you a chat prompt and a couple of things that you could go ahead and run and see what happens. If you give the right prompt, it gives you the exact thing that you're looking for. So the vulnerabilities are kind of highlighted here. This is the vanilla situation here, so there might be guardrails in the real world. And there's this last repository, which was part of a paper, and they devised this repository in such a way that you could install and do the exact same thing and run the demos as a script. It eventually gives you the same thing, how to break encryption and how to go ahead and get data out of it, how to change the understanding of the AI agent and such, right? Yeah, I'm going to share the links for all of these in the chat right now, and they're in the presentation, and I'm going to put that on the LinkedIn and Meetup pages too. That kind of brings me to the end of the presentation. Unfortunately, my machine kind of crashed. I had the presentation and the demo ready, but because of that, I am not able to show you the demo. I'm sorry about that. Maybe next time I'll be much more prepared. In case any of you have any input on this, the chat room is open. And yeah, Anuj, just go ahead, type it in. I'm gonna allow your mic so you could maybe talk. Yeah. You could unmute and say what you want.
Is I'm audible to you?
Yeah, you are audible.
Okay. My question is, there are different types of LLM models. Okay, and
Yeah.
everybody is
Yeah.
teaching their own. I think what I say, their own ethic, their own method to their own LLM. Okay.
Mhm. Mhm.
How could we ensure that uh, when we input something like gray area type question to that, like that joke on a religion and like that, you understand that gray area type? Okay, many LLMs are biased in their output. How could we ensure that we get a proper response in future LLMs?
I sort of feel like that's an ownership question because if it's owned by China, then they probably have a opinion that the Chinese government probably has. If they're owned by Americans, then they'll have an opinion that American governments have. But it's the silver lining here is that there are open source models now, which are available to be fine tuned. You can actually train your own models now. Go to Microsoft Fabric, you can fine tune your models. That's amazing because it's possible to go around all of this. The
Yes, that's
model
my question. Because even if Indians teach their own LLMs, okay, how could world ensure that they accept the whole truth as a final answer to this? Because I already told you that that's a gray area type, and we have to build a universal machine so that everyone can use that. uh, Otherwise, everyone has their own answer. How could an LLM and AI can grow in their own market?
But there's a gray area there because the AI cannot have the answers dedicated to 1%, one country or nation or religion because the sheer amount of data doesn't allow that. They could have an answer to a specific kind of questions. They can have an answer to a specific kind of a query, but it's not possible to change all of it because that all the rest 99.9% of knowledge is acquired from the internet, which is sort of a general blob of information. Most of these
Yes,
agents will have situations like this. Coding is a common example, which is neutral to nations and religions and everything. The coding knowledge is always mostly the same because it's acquired from sources like GitHub, which is neutral in this situation. Right? A lot of knowledge would still be relevant, and it is because it's context to businesses and stuff. It will still be relevant. But when it comes to those tricky questions, yes, influence will always be there unless and until you choose the third way of open source and maybe fine tune your model and have proper gradients around it. Yeah. But the bias
okay.
is pretty obvious. It's obviously going to be there because the creators would intend it. Even the open source community has struggled with this.
Yes, that's my question. Even I am working on a one basic LLM.
Uh-huh.
When the gray part were discussed in our team meeting, the same
Mhm.
question I put there, and they have no answer for this problem. They said you can leave that part to other team which were handling it, and they don't. They also don't have that answer for that. That's our project called Snowflake. Okay, we still have the same problem here. Okay, that the model is still in their developing phase and continuously facing the same problem because sometimes that gray part overtake the whole answer and they
Discussion.
yes completely uh, I don't know what to say. That's a blunder for everyone to discuss with client and everything. But thank you for your opinion on that. I think I have to like over and over again.
Oh, no worries, man. It's always nice to have a discussion around things that feel a little bit passionate. And thank you so much for being here, by the way.
Okay.
It's
Thank you.
always nice to talk to someone. Cool.
Uh,
And if you don't
Thank
have any other questions, I could conclude this, and you can have your day back.
and nobody is there. We are discussing only. Okay,
Cool.
thank you.
Yeah, no worries. You have a good one, man. And with that, I bring the session to an end. And thank you everyone for joining. Have a good one. Bye.
Bye.